Yes, Nelly, good afternoon. I will talk you through the relationship between botrytis levels and pears at harvest and the incidence at the end of storage. The objective is to determine the relationship with the presence of botrytis and then what actually happens during the storage phase to try and correlate the before harvest data and the after harvest data. Presently, there's very limited methods to monitor or quantify pathogen levels in or on the fruit at harvest to try and predict or to estimate the likelihood of decay development. The disease outbreak development is very unpredictable, as you know, the last couple of years as well. And also, we require control strategies for high-risk inoculum loads to try and prevent or to know at least what will happen with the fruit during storage. So the first part of this trial was to establish thresholds between the onset of decay and the level of the decay at the end of storage, and then also to see whether this is an accurate method, whether it can actually be used. We inoculated pears with known volumes of spores through the calyx end. Effectively, it was 20,000, 5,000, 1,000, and then different loads of spores. The fruit were stored at minus 0.5 degrees C. Visual assessments were done, but also then quantified using molecular technologies. Some of the results that I have, and this more on the visual part of it. If there's 20,000, the blue one right at the top. Is there, yeah? Is there a pointer, Richard? I think? No, not working. Is it there? Is it there? Oh, there it is. Right. So I've had the 20,000 is right at the top. So in the first week, nothing really happened. And then suddenly, and that's at 2 weeks results, it shot up to 100%. But if you look at the lower levels of spores where there's only 15 and 4, there was actually a lag, and then it started to develop. So even at the 4 spores in that inoculation site developed at a certain point of time. So that was a very good indication what could happen. And then we have to now to correlate this with the molecular work. Just a couple of slides showing the type of decay. It varies. Sometimes you have the whole fruit that is decayed, and other occasions it's less. And that also relates to the number of spores that were used. And then also, if you the bottom half was used for the molecular study, but you can see here that there's definitely differences in the symptoms expression. Sometimes only slight waterish color, and then in other occasions, the brown, and indicating that the pathogen has actually spread right through the fruit. So we are at this point of time awaiting molecular quantification. It has been done in this instance. We need to then correlate the pre-harvest and the post-harvest values, and then most likely we would like to extend it to other cultivars and also other pathogens in future. So it's definitely an opportunity to develop a decay management tool or model, and especially and then to determine the likelihood of disease expression at a later stage during storage. This will also benefit decision making for producers, but also exporters, to see what the storage potential of the fruit is, and also how the fruit should be marketed. Is it a low risk or a high risk parcel that will be sent, consignment that will sent overseas? So some success, but we are waiting some further results. Thanks.